Question 27 asks, find the critical points and apply the second derivative test to find relative extrema of the function f of x is equal to x cubed minus 5x squared plus 3x plus 6. So the second derivative test states that if f double prime of c is less than 0, then f of c is a local maximum, and if f double prime of c is greater than 0, then f of c is a local minimum. Otherwise, it's inconclusive. So if you get a value of 0, you can't state if it's a local minimum or a local maximum, and you'll have to use the first derivative test to find out what the local minimum and maximum are. So to find the local min and the local maximum of the original function, we'll first have to find the first derivative to find the critical points. So f prime of x is going to be equal to 3x squared minus 10x plus 3. So then we have to substitute 0 for f prime of x. So then 3x squared minus 10x plus 3 is going to be equal to 0. Then we just factor this, and we get 3x minus 1 times x minus 3 is equal to 0. So x equals 1/3, or x equals 3. Therefore, our critical points are 1/3 and 3. However, at this point, we can't say if it's a local minimum or a local maximum, so we'll have to find the second derivative. So the second derivative of the original function is going to be equal to just derivative of this, so it's going to be 6x minus 10. Now we'll take the critical points we found from the first derivative and we'll plug it into the second derivative to determine if it's positive or negative. So f double prime of 1/3 is going to be equal to 6 times 1/3 minus 10, and f double prime of 3 is going to be equal to 6 times 3 minus 10. So f double prime of 1/3 is just going to be negative 8, and f double prime of 3 is going to be positive 8. So now that we know which one's negative, which one's positive, we can say which one's the local minimum and which one's the local maximum. So since f double prime of 1/3 is negative, we can say that that negative 8 is going to be the local maximum. So since f double prime of 1/3 is less than 0, there is a local maximum at x equals 1/3. And since f double prime of 3 is greater than 0, we can say that there is a local minimum at x equals 3. So we found that the minimum is going to be at x equals 3, and the relative maximum is going to be at x equals 1/3. So if you're allowed to use a calculator on this section, you could easily check your answer to see if it's right by simply putting in the equation into your calculator, clicking graph, then doing second trace, find the maximum, and go into the left bound and the right bound. And you get the maximum to be 1/3, which is exactly what we got. And then we could just double check for the minimum, and you will get x is equal to 3, which is what we got. So that's how you can quickly double check if you have a calculator if you did the second derivative test correctly.